Yesterday in physics, while everyone was doing Valentine's Day stuff, we had a bit of a go in an experiment, again using the video from my cell phone to find out what the velocity of an object was. In this case, it was in relation to your red book, chapter 7, 7C, question number 1, where there was a trolley at a constant velocity, and then the rain was falling into the trolley, and it was investigating the momentum changes, if any, and the speed changes, if any. So the key ideas to remember through this question is that momentum is always conserved, and the extra mass means that velocity decreases, because you have P equals mass times velocity. Momentum is mass times velocity. If momentum can't change, then if mass is increasing, the velocity has to decrease. Okay, so here's what we did. We measured the mass of the trolley, and instead of using the rain, we substituted by dropping one of the remotes from the room onto the trolley. And this is the mass of the trolley here, and the mass of the remote was here, 0.254 kilograms and 0.110 kilograms. Now what we're doing here is two things. We're just measuring the initial and the final momentum. So using the mass measured and the velocity we're going to take from the video. I'll show you how to do that shortly. So using the mass and the velocity, we can calculate each before and after. We just want to see if they're roughly similar. This is not a perfect system because we're in a real world that has all of the usual inconsistencies and frictions and things. But what we really want to do is use this to try and predict the final velocity. And I've done the calculations here, as you can see. This is using just the initial momentum that we calculated from here, from the mass measured and the velocity which we're about to take off, and knowing that the initial and the final momentum are equal, rearranging momentum as mass times velocity here to find what the final velocity should be, 0.35 meters per second. So let's get stuck in. We're focusing here on this initial section where the initial momentum is initial mass times initial velocity. The initial mass, as I said before, we measured. We need to now look at the initial velocity. So here is a video of the trolley. This is the trolley on the right hand side here. It's sort of blue, dark color, and we've marked lines every 10 centimeters because it was a little bit hard to see the scale on the ruler. And this is Sam, I believe, was dropping the remote onto the trolley. So we're starting as close to that line as a frame we have. The camera is operating at 15 frames per second, so every 15 frames will give us 1 second worth of time. We're going to measure the amount of frames that it takes to go from this line here to this line here, so 20 centimeters, and the amount of frames. If it's, say, 3 frames, that means it's 3 out of 15, or 3 divided by 15 seconds to cover that distance. So if we have the distance and we have the time, we can calculate the velocity. So here we go. We've got 1, 2, 3, 4, 5, 6. It's about 6, maybe a little bit over 6, but we'll say 6 is close enough. If I go one more, we'll see it goes past it. So 6 frames, going back to our document here. And here's a text box I've prepared earlier for this. Our distance is 20 centimeters, so let's put that in meters, 0.20, and we are dividing that by the amount of seconds, which was 6 frames out of 15, which gives us around about 1/3 of a second. And if we perform that calculation, we should get, I'll just make my text box a wee bit larger. If we perform that calculation, we should get around about 50 centimeters per second, which is 0.50 meters per second. S to the -1. And if you've ever wondered how to get that little 1 sticking up there, you go into, the easiest way is just to highlight it, right click, format font, and superscript. There we go. And you could do the same with fractions, make the bottom one subscript and make the upper one superscript. and that gives us a momentum when we do the calculation of the mass was 0.254 times by the velocity 0.50, gives us our momentum of 0.127 kilogram meters per second. Same thing again to make that momentum. Oops, that didn't work quite how I was expecting. It's giving me issues to do with the yeah, okay, quick and easy way. Copy the units, paste. No. There we go. Okay, so using that information, 0.127 kilogram meters per second, for our initial momentum, our final momentum has to be the same. So we can substitute into that equation using the mass we measured and the momentum we now know to find the final velocity, which we got at about 0.35 meters per second. And that could range, depending how accurate. We're not measuring it the most accurately, but I suspect one significant figure is 0.3 and 0.4 meters per second is about the closest we can really get to that. So now we want to have a look over here at our final. We need to take another velocity measurement to first determine whether that velocity is going to be the same as our predicted velocity. So let's go back to our diagram here. We'll step forward a couple of frames. Boom, you might even hear a sound. No, the sound's off, that's okay. And I think it's best if we measure from, well, it's just giving me a little bit of grief right now, so let's just see if we can, I'm just going to replay the video, quicker and easier. Go to VLC, pause, step forward a few frames. Let's go from, I think that might be the closest we can get to the line. It's a little bit off, but let's see how we go. Ready? And 1, 2, 3, 4, 5, 6, 7, 8. That's about 9 frames to cover 20 centimeters. So 9 frames to cover 20 centimeters. Back to our Word document. Bring it over here. So the distance again was 0.20, and we're dividing by the time, which was 9 out of 15 frames. It's definitely slowed down, which was the answer to in the book, but we want to know relatively accurately, and that will give us a velocity, final velocity of 0.33 meters per second. And just because I get a little bit pedantic about details like this sometimes, which is a good thing, develop that pedanticness if you care to. So 0.33 is pretty close to 0.35, definitely within our range of uncertainty that we're not too sure about. So so far it's looking very good. And the last thing to do is just to quickly perform our final momentum calculation, which is going to be the mass, 0.364 times our velocity, 0.33. And you can straight away see that's going to be about 1/3. So let's quickly get out a calculator. I did the other calculations. 0.364 times 0.33 gives us 0.120. Okay, two significant figures, 0.12. So equals 0.12, again kilogram meters per second. Let's see if it lets me do the superscript again. This time it does. And you can see that 0.127 kilogram meters per second initial momentum, it's pretty close. We'd expect a slight drop off because of the inaccuracies of the real world with friction and so forth, but I consider this a success. Very good. Review the video later, you can see it in more detail and follow the process in a nice way, hopefully. Let's see.